Now we're going to talk about composite data types. Composite data types consist of arrays or records. An array consists of elements which are of the same type. Each element within an array is uniquely addressed by an index for a one-dimensional array, or indexes, or indices, for multi-dimensional arrays. Arrays fall into two categories, constrained and unconstrained. An unconstrained or constrained is one whose size is known, whereas an unconstrained is one whose size is not known. Here's an example of a one-dimensional constrained array type. The first line in my screen capture there is type one-dimensional constrained array type is array 1 to 100 of data type integer. Type byte type is array 7 down to 0 of type bit. Type dec type is array 1 to 42 of data type playing card type. Using the byte type as we defined above, we can instantiate a signal accumulator colon byte type, and we'll talk about signals in a subsequent session. Here's an example of a couple assignments to the signal accumulator. The first assignment is position association, and the second is names association. The first assignment uses an aggregate which addresses each element in an association list and assigns that element to a particular value. The others keyword applies to all the elements not specified in the aggregate. The others statement, if included in the association list, must be last. The second assignment uses a positional assignment of each element. Since the range is defined as 7 down to 0, the leftmost element is at index 7 and the rightmost element is at index 0. We can also access only portions of the array if we so choose, i.e. slices. Here's a screen capture where we're addressing from accumulator 7 down to 4 as being 1010 and 3 down to 0 as all being defined as all those positions defined as 0. Since the byte type range is descending by virtue of the 7 down to 0, the slice range must also be descending. Now we're going to look at unconstrained array types. In the first line of the screen capture, type integer vector is array begin paren natural range less than or greater than less than and greater than end parenthesis of data type integer. That defines the unconstrained array type. When we actually use it, though, we have to define exactly how large, or we have to constrain the array. So signal quizzes integer vector type from 1 to 10. Here we have an aggregate assignment where quizzes at locations in the array 1, 3, 7, from 7 to 10 is initialized to 95, and all others are initialized to 45. We can also define multi-dimensional array types. Here's an example. Type matrix type is array 1 to 3 and 1 to 3 rows and columns of type real. The next line is we're instantiating a signal called matrix with the data type matrix type. The next screen capture is basically a assignment example, and here we're scanning through the array, two-dimensional array, one element at a time, and we'll be looking at things like for loops as well later, but this shows you the indexing of a multi-dimensional array type. There are implicit functions associated with array declarations. The first we'll look at is assignments. Specifically, when you assign an array, the source and the destination must be of the same type and the same size. We can also perform relational operators on arrays. For each element of the arrays are compared from left to right. If the comparison is true, then the relation is declared true. If not, then the next element is compared until all the elements have been exhausted. Here are some examples. All these examples return true. AB is less than BA because A is less than B. 2, 9 is less than 9, 3 because 2 is less than 9. And done is greater than do. The last example is true because there were still elements left in done when DO was exhausted. We can also test for equality between arrays. If we compare two arrays, it returns true if both operands are of the same types, size, and each corresponding element is equal. For the inequality operator, each element of the arrays are compared one at a time from left to right. If the relation is true, then the comparison is declared true. If not, then the next element is compared until all the elements have been exhausted. Therefore, here's a few examples, all of them returning true. AB is not equal to AC because A and B is equal, but we move on to the next one and B and C are not equal. 2, 9 is not equal to 9, 9 because 2 is not equal to 9. And done is not equal to DON. The last example here is true because there were still elements left in done when DON was exhausted. The concatenation operator, ampersand, both operands must be one-dimensional arrays of like type or base type. For instance, the following are valid concatenations. Hello concatenated with a space concatenated with world, which would give you hello space world, and zigzag, which would concatenate the words zig and zag, no space. Also, when we're taking a slice of an array, the slices must be one-dimensional. Also, we have predefined attributes for array types and their objects with the same syntax as before. A, which is the base type or object, tick, and then the attribute name. We can select the left bound of an indexed a range of A, right bound, such, so on and so forth. We can also check to see if the array is ascending or descending, and return also the array length. A record consists of elements which may or may not be of the same type. Each element within the record is uniquely referenced by its name. Record aggregates, like array aggregates, can have name or positional association. Here's an example of a user-defined data type of type record. The type music track is record, and it has elements song, artist, genre, year, and so forth. And there's a signal instantiated with that data type of name album. Here's some signal assignments using a record data type object that we just defined in the previous slide. I can say album.song is assigned string let it run. Album.artist is assigned with string Jeff Lynne, and so on and so forth. Or I can do it a named association. Song, let it run, artist, Jeff Lynne, and so on and so forth. Or I can do it positionally. Album is assigned with let it run, Jeff Lynne, soundtrack, and so on and so forth. So all three are actually equivalent.